Continue with part 2 of the walkthrough on how to make a Summit Scheduler game. Now we've created a simple run.py that is a cut and paste running the cart pull game that comes with the simple example from Gymnasium. And what we would like to do is create our own custom environment. And you figure this out kind of by looking at the run.py and realizing that Gymnasium is making this environment, and the environment has this interaction cycle with the main game loop. So what we want to do is replace this cart pull environment with our own environment, which is going to mimic the kind of actions and the kind of observations that we want to make inside of the Summit Scheduler. So to do that, of course, we'll just go ahead and start Googling, make a Gymnasium environment example. If you go to the very first Google hit, you notice that there's kind of a dead page and it doesn't take you anywhere. So you can scroll down. There's a lot of good tutorials you can find on making a custom environment. And then you see a link to what you're really looking for, the documentation that comes from the Gymnasium package itself. Luckily, they provided this link for us on the landing page that we just reached. So they give us some instructions on making our own custom environment. And they're telling us that a repository exists which contains this environment, and we can change into it and start to install. So here's the create a virtual environment, activate the environment, and install. That's the usual stuff. We already have our own virtual environment. So what I'm going to do is cd ... run this git clone command. And now that I have the git clone command, I want to look at this example and see how it's set up. They don't have a poetry file because they don't expect you to develop poetry. This is just a simple setup.py, which uses the Python setup tools setup function to say my dependencies are gym and pygame. It looks like if we're going to make our game playable, we'll also have to add a pygame dependency. So inside of our actual game here, we're going to have to run poetry at pygame. Adding all of these dependencies will now make it will now give us the library that we need to actually display the game. All right, so that's one piece of information we got from the example. The other piece is inside of gym examples, there's a standard init like you'd expect before, but this init contains a call to a register function, which is going to allow us to create our environment. Here they're calling it grid world environment, but this register function, when we run it, will probably register our own environment with Gymnasium. So let's copy that. In fact, we don't even have to change there. We'll just put it in. All right, from gyms and registration, import register. Now, I've actually run through this before, and I've noticed that this example is kind of old, and this isn't going to work. It looks like this is coming from the new Pharma Foundation gym examples, but it's importing from gym ends registration, and this doesn't work because the old gym code has been updated to Gymnasium, and so all of our names have to change from gym to Gymnasium because moving forwards, this is just the name of the library now. This register function hopefully will act the same as the old register function did. And notice we're giving this an ID and an entry point. And thinking a little bit about this, I also want to rename my game so that rather than just calling it kind of generic job game, I think we ought to call it overloaded. It's just a cooler name. So my game is going to be called Overloaded, and the ID of the game will be Overloaded V0. The entry point will be Overloaded ends overloaded. Now, Python has a way of naming files and objects inside of files. So this is actually going to be package name overloaded subdirectory envs, and this colon means I'm looking for something inside the module envs, or inside of the module envs. And so this overloaded here will have to be a class that I can import when I import envs. So let's do that. We'll create an overloaded envs overloaded. I'll have to rename this directory job game to overloaded, and I need to make this directory. And after I make this directory, I need an init.py. This init.py, init doesn't have to contain anything in order for Python to see files inside of that subdirectory, but if it doesn't contain anything, then I would, if I put a class overloaded inside the file envs/overloaded, then I would have to call it envs.overloaded :overloaded. And that would just be way too verbose. So what I'm going to do instead is I'm going to import overloaded into the main envs namespace so that I can just call it envs:overloaded. So this is making a synonym up one level. And now I actually have to make this file. All right, so we'll just put in a stub for now, but all of the import information is there. I now have envs/overloaded with an overloaded class, and overloaded, so envs now contains the overloaded class that it loaded from the current directory's overloaded file. So we're just kind of looking through the example. You notice they did the same thing that we did, except that rather than, I put a dot here so that it loaded from the current directory, and they used a fully qualified name. Either one should work. Let's see, their grid world env is going to be imported here. So now this grid world is information that I should mirror inside of my own overloaded file, which should contain a class. Just paging through, this file is kind of on the largest side, but it does only contain one class, the grid world env class. And you'll notice it's extending gym.env. So what I want to do is maybe start with a very simple basic game, but I'm tempted to just cut and paste all of this. Let's do this. I will split the screen and start editing my own copy of this. So my copy is blank right now, but I wanted to extend gym.env. And of course, for gym to be visible, I have to use the new import method that we get from the documentation. Oh, here it is. Our custom environment will inherit from the abstract class gymnasium.env. So notice there's a difference in naming. The example says gym.env, and so in order for this to work, we have to actually make the import line look like this. All right. Now we will also need spaces. And actually, I always am a little bit uncertain about how the import statements work. Just to be on the safe side, we'll call this gymnasium. Whether I can import from a module that's already been loaded and aliased, I don't think so. So we'll just call this spaces. We'll also need pygame and numpy. All right, so now we've got all these imports. We can start coding the actual class itself. So from what we know so far, we'll need an init and a step function. And this should allow us to run our example. There's probably some other practices that we generally want to copy over from the example, because as pygame is instantiating its environment, it'll expect our environment to be set up pretty much the way that the grid world example environment is set up. So it probably wouldn't hurt to add in metadata that's similar. looks like we're going to have to define a human in an RGB array render mode. We can also pass that render mode to our init function. Why not? More information should be better. There may be other parameters that we want here, maybe max queue size. And we'll schedule it on 4600 nodes. All right. Inside of their init function, they're defining things like the window and the layouts. Let's skip that for now and go straight to the observation spaces. I should probably at this point start documenting what my mental image for the game is going to be. So I don't really have space on this screen. Let's just put it in here and we'll copy it later to a nicer place. The observation space. Is usually going to be a set of jobs, but we don't necessarily want to have a set of jobs just like a whole bunch of jobs as an observation, because this won't map very well to a fixed size vector. So what we could do instead since there's many jobs in a bucket, we have these summaries, and we only ever really want to run the highest priority job in every bucket. So if I choose a job in the small bin, the small job size bucket, then I'm going to run the highest priority one in that bucket. So I have some amount of choice as the player to say which job size I want to run, but I don't have the choice to pick which job in that bucket just because it only makes sense to run the highest priority one at any given time. What other information should we have? Number of jobs, priority of the highest priority job. We can put more information, and so as you kind of think about what information you would look at as a player, you would see all these jobs and you would kind of look at where these things are. Maybe we can do the next highest priority job, or maybe number of jobs in the bucket. With non-zero priority, because we know the priority will only go up over time. And some nice documentation. So now that we've described pretty much what we want to do, we can start making these spaces a little bit more clearly following what we're doing. We'll want to have a dictionary space, works fine. Looks like we need to create a dictionary syntax. And we'll call this so I always go back to my documentation here. The array of observation representing the properties of the jobs. So let's call this jobs. And we also need the utilization, right? So this will be a nodes bucket. And this spaces.box, which is used in the grid world example, this is just a two-dimensional location from 0 to size -1 and from 0 to size -1. We have more than this two-dimensional location. We've got kind of a very large grid array, so we will need a different kind of space for jobs. But the space for nodes is going to be very similar. It's going to be this two-dimensional thing with integers. And the max number of nodes that we can have is going to be, where did we put that? Inside the init function, right there, max nodes. Yep. 0 to max nodes. And it just so happens for us that max nodes is the natural upper limit for both the number of available nodes and the number of used nodes. Maybe there's some sort of system administration actions which remove some of the nodes from being schedulable at a given time. All right, so the syntax is still good. Let's just combine some lines. Yep. And for jobs, we're going to need a different kind of space. So let's look at the environment documentation. Spaces. All right, looking at the API documentation for spaces, action space is discrete. That's definitely going to be useful. Let's cut and paste that right away so we don't forget it. N is something that we defined in our documentation, so we probably also ought to have it reflected here. Let's say defaults to 5. Actually 4 would be easier because I have 4 fingers to play the game. Now, there's a question as to whether this includes 0 all the way up through n, so let's check the documentation. If there are 3 possible actions, discrete 3 means that, and I have n boxes, so I actually need my action space to be n plus 1, because now I can represent 0. I just want to put a little bit of documentation here. One is bin 1, class 1. Let's give this documentation a little more space. So our action space is defined, and we also have a node space as an observations, but we don't yet have the job space, so we do so. All of our spacing is wrong. Great. So far, so good. We don't need these underscore methods. We do need to have these basic things that come from a gymnasium environment. Reading through the documentation, they say your environment class should implement these methods. And they should do step, reset, render, and close. So I will now implement inside of my game step, reset, render, and close. Probably reset is the one that would go first. Step and render should be called back and forth. And then we have a chicken egg problem. We probably want to render the environment before we call step, because step requires an action. The order of these, of course, doesn't matter in Python, but mentally it's nice to have an order that maps to the way the game works. All right, the reset function, we can have a random seed. It's all well and good. Maybe we'll copy that functionality here. And we'll call our superclass. I'm going to keep the comment in here so that I don't delete it later thinking it's not necessary. In their reset function, they're of course going to mimic hitting the reset switch and reinitializing all of the information. We're going to have a render function that takes some internal information about the users and the jobs, and then turns that into an observation. So inside of our reset, we actually need to start messing with our internal data structures. We'll have something like self.jobs, which we will now reset, and self.users, which we will also reset. So now we've reset everything. We should think some about how many users we want to have in the system. Let's do this. And if I just multiply by n users, this will make a copy of whatever user structure I put in here. So I'll have some sort of user class that represents what the user's current state is. But I don't just want to multiply this, because then if I change user 0, it'll also change users 1, because of the way the Python memory model works. So I have to actually write it this way. And by doing that, I now make independent users. So now that we've copied over the main game loop structure into our package from gym examples into job game, it's time to run a test and make sure that the syntax is correct and that we can run the major functions inside the program. However, before I do that, I also want to rename this generic job game into something I've thought of that sounds a little bit better. So we'll rename the main directory. We'll also rename the metadata. And we can double check that the old name doesn't exist anywhere in here. We'll rename it inside the README. Looks like it's there. And now we want to make sure that all the imports work correctly. Looks like this test import worked. Probably want to run poetry run install again, or not poetry run install, but poetry install. Let's make a new test that contains that run of the main game loop. Well, let's work from an import. And in order to make this work for me, what I'm going to do is look up the example run method so that I can cut and paste. And what I should be able to do is import this class and run the methods directly, or ask Gymnasium to do the import for me. Maybe if I scroll at the bottom, this example will say what the main loop will run. Here we go. Let's double check that this import matches this init statement. Nope. All right, so this is the ID that I want to import, and let's just double check. Everything looks good. Let's just print it for fun. And we'll run that test. All right, so now that the import code exercise, we found our first syntax error sitting inside of the environment, which is nice. We can run this test over and over and clean up all the syntax errors that exist inside of this directory.